Okay, I think we are good to go. Hello everyone, good evening. Welcome to the tutorial class 10 of problem solving through C programming. So, uh, so today we will be learning about pointers. So various ways and how we used to do the pointer arithmetic and what is the you know how we can pass pointers as a parameter to the function, and we will be learning about how to return a pointer from the function. And I think we just had that glimpse in the last class also, but I will try to cover that in detail, and then we will talk about the dangling pointers, and there will be small quiz towards the end. So I think this will be a short class, and you need to. I just want to focus on, because professor has been using pointers in several locations, and I think some of the people are. I mean, from the last class feedback, I got to know that bit struggling regarding the pointers and how that particular thing will happen, and how to dereference the pointers and all this stuff. So this tutorial class is dedicated to pointers. So let's get started. um, Let me stop my screen sharing, and so let me share the whole screen. Okay, are you guys able to see my screen, whole screen? Okay, cool. So so the fundamental thing, I was telling this thing quite in the previous class and earlier classes. So basically the thing we need to understand is a pointer is a variable which can store the address of another variable. So we all know that, by using ampersand symbol we are able to get the address of that particular location or particular variable or some memory location of a array or whatever it is. So we use ampersand symbol till now to use the find the address of a particular variable. So pointer is a special kind of variable which will store such a kind of address. So if you are able to understand from this code, so let's say if you have a integer number 10, so the address of this particular number is this one. So pointer variable actually stores this number in store this particular value in another variable. So that variable is called as pointer variable. So this is what I was trying to explain you. So number is there, and you have the value here in this particular location, and pointer variable will save this address in its location. So this is the important thing that you need to understand. So and there is one key thing that you need to understand is, let's say if you want to store the integer variable address, so you need to use the integer pointer. So data type should be matching with the where variable name is stored. So variable name will store in memory. So let's say if you have some program, so that program will be given, let's say whenever it is executed, you will have a stack segment, data segment, code segment, stack segment and heap segment. So if you try to learn it by using, you can learn that in microprocessor and microcontroller. So whenever you try to execute some program, so each program will have a specific stack, heap, data segment and code segment. So from that particular stack segment, I think the variables will be allocated, values will be allocated, and you will have a memory location there in the stack or something, stack or heap. So based on your allocation, so that memory location will be given to you. So that's where that is the place where the variable value will be stored, and pointer variable will store that particular address. So that is what
So variable name and variable value have same address in different databases, in different
yeah,
structure.
I think you will get to know that with this example, Arshad. So let's say I think it's better that I will show this code to you. So let's say we consider this program. So initially we have an integer variable 10, right? So by using ampersand symbol, we will get the address of this particular variable, right? So we are assigning that particular address to the pointer p, which is also an integer type. So integer pointer can only store the address of the integer variable. So if you try to print the variable value, value of the variable, you will get 10. So if you try to print the value of star p, so which will point to the value of that particular variable. So if you see from this code, whenever you are trying to print the address of variable, you will get the same value, and if you are trying to print the value of p, you will also get the same value. So fundamentally, if you are trying to print the value address of p, you will get the different value. So fundamentally what happens here is eventually this one, so you have a variable 10 which is there in this location, and pointer variable will store that location, and whenever you try to dereference it by using star p, so it will go there and it will find the value in this particular variable. That's what happens. So that's why whenever you use star p or star some variable, it will try to get the value. So but when you are trying to print only the p, you will get the address of that particular variable. Okay.
Okay.
Okay. So that is all about pointers. So there are some key things. So this is called address operator, so ampersand. So this is used to assign the pointer variable. So this is used for allocating a so star operator is called as access, whenever you want to access the value of that particular pointer variable, you just need to use the star. So star will give you the value in that particular memory location. Whenever you directly use p, it will just store the memory location. So you from this snippet you will understand that, see, whenever you are trying to access p, you will get the address of that particular variable, but whenever you are using star p, that means it will go there and it will fetch the value that is stored in this particular location. That's what the fundamental difference between p and star p. So this is about pointer basics. So one thing that you need to understand is, so you need to have a same data type as the variable name in order to assign the value to that particular pointer. So pointer value and the variable value should have the same data type. That is a fundamental thing. So I think we will start with pointer arithmetic. So till now we have seen how to use the pointers. So now we will try to understand what kind of operations can we do with pointers. So there are, what happens if you do +1 with pointers, and how do we dereference the pointers. So I would like to explain this in a simple terms with this one dimensional array. Let us consider this array of single dimensional array num, which is having these values. So whenever you assign any value, let's say if you write star p equal to ampersand num, so you will get the starting position of the array. So that means this position where the number 0 will be stored. So whenever you try to you know how to access all the elements in array, right? So 0 1, yeah, Swati, I think somebody has raised hand. Okay, so by default the value will be the pointer will be pointing to the first location of the array or memory. So then what happens is that whenever you try to do +1 with the pointer, then it will move towards the next memory location. So if it is an integer, then it will shift 4 bytes. So based on the data type, if it is a float, it will shift 8 bytes. something like that, you know. So let's say let's say num plus 1. So what num plus 1 indicates is that, so by default value of the pointer will pointing to the 0th element. So plus 1 means it will point it to here. So it will shift 4 bytes from the right side towards the right side, and it will you know, it will do the addition to the memory location. So it will do base address plus I star size of memory. So that means in this case base address is, let's say number 0 is there in 5000. So 5000 plus here number, let's say we try to dereference this in num plus 2 means 5000 plus 2 into, this is a integer array, right? So 2 into 4, that means 8. So it will go to 5008, and in this location you will get the 16th value. So star means you will go to this memory location and you will get the value, fetch the value in this particular memory location. So that's what we calculate. That's how we calculate you know, pointer arithmetic. So that means you will jump the memory locations by adding plus 1 or plus 2 or minus 1 or minus 2 from the base address. So that's what the pointer arithmetic means. So I think you will get a better understanding from this example. Let us try to understand this program. Let's say I defined a number 50. So I assigned a integer pointer, and I tried to assign this address of this number to this particular pointer. So so what I was trying to do is I will try to increment this pointer plus 2. So then we will try to see what happens to this you know, location or value. clang. So you can ignore the warning. So the value of p is 50. So before incrementing, so after, okay, so it's my bad. So after it should be before increment. So before increment, the address of variable is 76. You know, this is some memory location in my computer, and you just need to understand these two values, because where that's how you will understand how the arithmetic will happen. So the base address is, I mean the point number is there in this address. So I did plus 2. So that means the integer by default the size of integer will be 4 bytes. So whenever you see plus 2, that means it went to you know, it jumped 8 bytes after that particular memory location, and the particular now the new address will be, you can see that it is 84, that means 448. So if you try to do minus 2, for example, let me recompile. So before increment, so you can see that the base address is 56, and you can see 8 bytes it went backwards in the same memory location, you know. That's what the pointer arithmetic means. So that's why whenever you are trying to access these locations by using you know, you can access the sequential elements in array by using pointers, and that's what the high level understanding of the pointer arithmetic. So now let us try to understand with detailed example. So this is a case scenario. Let us assume p of data is a float pointer, and it is initially assigned to, and you know, it was there in base address is 2000. Assume that it is there in your memory at 2000, starting at 2000 address. So what happens if I do p of data plus 1? So what happens if I do p of data 1 means it will take the base address. So p of data plus 1 means plus 1 into size of the float. So it might depends on the compiler. So assume that it is a 4 bytes in your compiler. So then it will moved to this particular location. So 2004 will be the resultant address where it stores. So the pointer will be, let's say pf data is there, pf data plus 1 means the pointer will be shifting to this particular position 2004. From 2000 to 2004 it will shift. So similarly, if you do the pf data minus 2, so it will, in the memory location it is 2000, so it will the pointer will move to 8 memory locations, 8 bytes before the base address. So that means it is 1992. So similarly, you can go through this. So the my intention of telling all these things is that, so you can shift from the base address to access different elements, and sometimes you might get the proper values and sometimes you might get the garbage value. So you need to be very careful while shifting the pointers. So this is the thing that I want to explain. So now we will see in detail how we can use these pointers to traverse in array. So I think from this example, let us say you have a array of a1, I mean a of 3 equal to 1 to 3. So we are trying to we are trying to use the star p pointer to point it to this base element of the array. So just like how you use in a typical for loop, you can use pointers to traverse across uh, all the values in the array. And there are few things that you need to be very careful about. So first thing is, let us consider this example. So a of I, printf percentage a of I, all we know, it will give you the value of the particular variable located in the index. So there is another way of representing that as well. So that is called I of a, that also the same. So it will also the print the element of that particular array at that index. So this is also a legitimate. So maybe in some quizzes or some other competitive exams they might ask you such a kind of questions. So you need to understand that this is also a valid statement. And as we discussed, so a plus I means it will print the address of the element. So because it is not dereference, so you will get the address of the elements based on the I value. So if you increment the I, you will get different addresses in the array. So similarly, if you try to point a plus I in the star, so this is called as dereference operator. So star is called as dereference operator here. So it will fetch the value in that array. So value of that particular let's say if it is a plus 2, that means it will print a of 2 value. That's what I mean. So I think we will try to cover this basic stuff in this thing. So I want you to answer what will be printed in this from this program. So you have a array arr of 5 means 6 2 3 4 5. So I have printed set of statements. So can somebody guess what it will print here? Arr plus 1.
For first, I think we should get the pointer value of ARR.
Okay.
For second, we get the second pointer value of second element.
Okay.
And third, we get the pointer address, not value.
Okay. Third, what you will get?
Pointer address,
Address,
memory address, or I should
memory
say.
address. Oh, I see. Okay. Fourth one.
Fourth one is little confusing.
So, so here you will get the address. You will get. So let me try to compile it, and we will see the magic. So pointer. So first you are right. So it will point out to the base element of the array. which is ARR of 0, and ARR plus 1 will be pointing it to the address of this particular location where 2 will be stored. And surprisingly, you can see that the ARR plus 1 will give you 7, because as we know, star ARR is, it will dereference the value. So dereference the value means 6 plus 1, which is 7. So you need to be very careful with what is ARR plus 1 and star ARR plus 1. So if you want to print the value that is there in first index, so you should be putting that in the bracket. So whatever the value is there, it will dereference it right away. So whenever the star is there before any variable, so it will try to dereference the that pointer, you know. So let's say if ARR plus 1 whole thing will be there in the parenthesis, then you will get whole thing. So that means it will first do ARR, it will go to ARR, and plus 1 means it will shift to this address, and then it will try to dereference the value. You got it? So similarly, if you want to iterate over all the elements of the array, you just need to use just like how we use for I equal to 0, I less than 5, I plus plus, printf percentage d. What we typically used to do is ARR of I, right? So this is almost equivalent to ARR of I, right? So the star p plus I represent the same value as ARR of I. That's what I intended to say. So you should be very careful when you are dereference the pointers. So that is all the things that I want to tell you about the single dimensional array. So by this time, okay, you are cool enough and you know how to deal with the pointers, and then you say that okay, very good, I'm able to understand pointers and I can traverse over the single dimensional array, and good. So now the fundamental thing that you need to understand is there is some tricky thing happens in terms of two dimensional arrays or multi-dimensional arrays. So I would like to concentrate that one as well in this class. So let us assume you have a 4 by 3, right? So 3 by 4 matrix, and you have a 3 by 4 matrix, and this is how you will be represented. So 1 2 3 4. So initially the base address will be pointed to excuse me, base address will be pointed to first element of the array. So then if you do the ARR plus 1, unlike the single dimensional array, it will not move horizontally here. So if you do the ARR plus 1 in the single dimensional array, it will move here, but whereas in terms of two dimensional array or multi dimensional array, it will move towards the row wise. So if ARR plus 1 indicates you will be going towards the first row, ARR plus 2 means you will be going towards the second row. Then the fundamental question that arises in your mind is that okay, you said that okay, 0 1 2, so it will go in row wise. Then how do we access the element that is there here? So I want to access 11, how do you access? So that is the question, right? So in order to clarify that question, I would like to show you some example. Let us consider this program. Let me try to clear the console, and let us try to consider this program, and we have a 3 by 4 matrix. You can say that this is a multi-dimensional array of row size 3 and column size 4, and we have all these values. So I would like to print PTR. So first star PTR. So it is not star PTR, you can see that it is star PTR. So the star PTR indicates that you are using multi-dimensional array. So you are telling the compiler there is a fundamental difference between single dimensional array pointer and one multi-dimensional array pointer. So you need to, let's say here the defining, in the previous case you just defined that star PTR equal to ARR, but you can see the subtle difference between this pointer and this pointer, because you are saying that I have a star ptr, I mean integer pointer, which is of column size 4. You are saying that okay, I have 4 columns, right? So then you are assigning the array to that particular pointer. Then star ptr will point to the 0th element, I mean the base element, so 10. So star I mean ptr plus 1 will indicates, as we discussed, star ptr plus 1 indicates the first row, star ptr plus 2 indicates the second row. And if you want to traverse across the columns, let's say if you want to print what is there in this particular location, you just need to print, you just need to use, first you just need to dereference, you need to come here, right? So you need to come to the first row. For coming to the first row, you just need to use the pointer ptr plus 1 and you need to dereference it. Okay, then you will get a whole row. In that whole row, you just need to traverse 2 locations. So you need to traverse 2 locations, right? So then you need to use plus 2 here to this whole thing, and then you need to dereference it again. So final output will be like 22. Okay, so this is how it will be. So if you want to access this particular value, you just need to come here, star ptr plus 2. So it, as we discussed here, so arr 0, arr plus 0 means it will point to the first row, arr plus 1 means it will point to the 0th row, first row, second row, and arr plus 2 of you need to dereference it, plus 4 means it will 0, 1, 2, 3. So 3 will give you the location of 12, right? So that is how it will be. So let us try to understand. So you have, let's say if you want to access ptr of 0 comma 0, 0 comma 0 means 10, you can use star ptr because it will point it to the base location. So if you want to access 1 comma 2, so you need to come to the first row, second column, you will get, you need to use ptr 1, come to the first row, and you just need to access the variable by using plus 2. Okay, then using the same thing. So just need to, I will just try to compile this code. See, you can see 10, 22, 33. So ptr 0, 0, star ptr means you will get the base address of the whole array, multi-dimensional array, two-dimensional array, and you will get it as 10. So if you try to access location 1, 2, so you need to use ptr plus 1 to come to the first row, then you need to use traverse 2 locations. So 0, 1, 2. So here you will get 22. Similarly, if you want to access 33, so come to 1, 0, 1, 2, then 0, 1, 2, 3. So you will get the last value. So this is how you do the pointer arithmetic on multi-dimensional array. So, and if you have more dimensions than 2, you just need to dereference it again and again by using, let's say if you want, if you have 3, 4 and some 5, it is a 3-dimensional array. If you want to dereference it, then you need to use something like this one, plus 4 or something. You just need to use like this to dereference the value. I am just giving you an example. You can explore more on it. I have provided a detailed links for all this stuff. So this is about how we use the pointer arithmetic on multi-dimensional arrays. So now we will try to understand how we use pointers as a parameters to the function. So this is just like any other argument, we can use this thing. So when we are passing a pointer as an argument instead of a variable, the address of variable will be passed. So we have seen that in the previous classes. So that is called as call by reference in C programming language. So this is a basic fundamental program. So let us assume you have a integer salary and bonus. So you can scan the value by using scanf percentage d salary, and whatever you are asking the employee what is the bonus. So bonus will be, let's say it is 2000. So you just need to add the bonus to the salary. So you are calling this particular function where it will take integer integer pointer. So you just need to pass the address here, so that it will be called as call by reference, because the original variable value will be passed as an argument, and it will be modified there in the function which we are calling, and it will be coming back. So whatever operations that we perform here will be replicated in the main program as well. So if you just pass the value, this value will be just copied, and it will not impact the value that is there in the main program. So we have seen that example in the previous class. So um, I just want to reiterate the same thing again. So we just need to pass the address value here, and here you can see this is the integer pointer, and you do the operation on the integer pointer, and the final value will be replicated. So if you try to execute this program, 10,000 and the bonus will be 2000. So that bonus and the salary will be passed, and we are passing the address of the salary, so that this program in this function, whatever the manipulation, so we are adding the value of the bonus to the main salary, so that value will be replicated in the main as well. So after returning from this particular salary hike, you can see the final salary will be 12,000. So this is typical example of call by reference, and that's how we pass pointers as a parameters to the function. And another thing that I would like to cover here is returning a pointer from a function. So let's say you have some function, then you try to return the pointer to the function, from the function. So how you do that in real time? So this is a sample program for this one. So in the main we have a array 11 12 13. So it is a single dimensional array of size 4 or 5. Okay, it is 5, size 5. So you can see the base address. We are trying to print the base address, then we are passing a return pointer. We are calling the return pointer function by passing array and integer I. So here you can see what this particular return pointer will do is, it will the declaration is different. You can see that the star will be there, star return pointer. So it is telling the compiler that the pointer will be returned from this function, and you are passing address of this particular variable and integer. So what this particular function will do is return pointer. So it will take the array and it will do the pointer arithmetic. So it will increment the index, so that the pointer will be shifted to some other location, and it will return back the pointer to the main function. Here we have declared the integer pointer, and because this function is returning the integer pointer, so we are declaring the integer pointer here and assigning that particular value. And initially the base address will be pointing it to the 11, and based on the I, so here we have passed I equal to 4. That means it will increment by 4, 0 1 2 3 4. So it will point to 55, and so the final output will be 55 in the PTR. So you can see the base address of this array is something with ending with 36. So after incrementing 4, so it is integer. So 4 4s are 16. So 16 will be added to this particular thing. So the pointer will move to that particular location in which it will have 55. So we are incrementing by 4, right? 0 1 2 3 4. So it will point it to here. Okay. So this is how we return the pointers from the function. So this is another important thing. So since we I just try to, if somebody can understand, can't understand in a single go, I just try to give an explanation for you to dig more into it. So since the name of the array is a pointer to the 0th element of the array, here we are passing the two argument to the return pointer ARR and by call by reference, and another thing is I value. So inside the function pointer p is incremented by n by using pointer arithmetic, and the p value will be reassigned. So you will see p equal to p plus n means it will move towards 4 4s are 16 bytes towards the right side, and that particular value will be assigned to the pointer, and that pointer will be returned back to the main function, and based on that particular value you can dereference it to get the, here we are trying to use the star ptr, so we are trying to dereference it, eventually we will get the 55. Okay, this is how we return pointers from a function. So now I will conclude this class by telling about the dangling pointer. So we have seen how we can return from the pointers, right? So as Arshad pointed in the earlier in the class. So let's say if you are trying to point the pointer to a location where it is deallocated, the memory is already deallocated, so such a kind of pointers are known as dangling pointers. So it don't know where to look for, and sometimes, so dangling pointers mainly occurs because of, let's say you assign some pointer value to a pointer variable, and then you suddenly dereference the memory. So maybe out of scope, and it will go out of scope, that particular variable out of scope, and you try to call the wrong function, and the return value from the function may be wrong, and using the malloc calloc, I mean, you don't know the, at this time you don't know the malloc and calloc. So malloc and calloc will be used for dynamic allocation of the memory and all this stuff. So whenever you are dealing with such a kind of pointer, so if the pointer turns out to turns to pointing out to the location where it is already dereferenced or it is out of scope, so it will point to the location where there is nothing. So such a kind of pointers are called as dangling pointers. So for example, consider this case. So okay, in the main function you call a function. So it is some small function, you call that particular function, and here you have a temp variable, and you assign the value of temp, and it will return the I mean that this function will use to return the address of the particular temp to the main function. So the moment it comes here, this is a local variable, right? So this is not a global variable. So this local variable is not in the scope of this particular program in the main block. So eventually, after returning it to here, when you are trying to dereference it, eventually you will get a garbage value. So that's what the whole point. So you think that, okay, this particular ptr will have the value of 10 when you try to dereference it, but eventually it turned out to be you are having a garbage value, or sometimes it will throw the segmentation fault as well. So such a kind of pointers are called as dangling pointers. So the high level idea is dangling pointers are those pointers whose address it has been pointing in the memory, which is no longer utilized, and it has a value that will be rejected by the compiler. Okay, so Pratiksha, yeah, you can ask the question. Sushma, address of, okay. Pratiksha, if you have any questions, you can ask. I think you have raised the hand. Okay. Anyway, let us try to look into that with an example. Let us assume, okay, I have a main function. In this function, I just called a my pointer function, that's it. So in this my pointer function I have a temp integer variable which is having value 10 stored in it, and it is a local variable. So you can see the temp is a local scope, so it is not declared globally here. So we are trying to return the temp value here to the main program, and the PTR eventually will get that address of temp. So when you are trying to dereference it here, you can see dot slash dp2. So ideally we should get 10, but because this is a dangling pointer, you will get 0xa. So this is some random value. Okay, this is how dangling pointer. So you should be careful. So one of the ideal solution is that
Will the value change? I mean, for every run of the program, or it will static. I mean, for a particular program or for particular system.
it will depend on the compiler. So maybe if I run, I don't see in this compiler it is working, but eventually sometimes you might get a segmentation faults, and sometimes you might get a garbage value which is there, because my Mac is this compiler will work bit different. So that's why I'm not able to tell you that what will be the dynamic, I mean, for each run. So
I
you
mean, my
can
question was like, it depends on the system, right?
yeah,
I mean, it will be static for a particular system, but it will change vary for other systems.
yeah,
But
that
it will be a random value.
yeah. So because it is pointing to some other garbage location which is no longer useful, or compiler has no vicinity on that particular location.
Okay.
Okay,
Thank you.
yeah. So Pratiksha, you still have any question? Okay, so
So
yeah.
if you recompile the program, then it changes the location or not?
I don't think so. Let me try that. I didn't try that. Let me see lang dp2.c. No, in my case it is not changing. So I tried to run it in online compiler, then I got some segmentation error. So you can check that. Okay.
Okay.
Okay. So uh, so I tried to give some explanation for this code, because the pointer PTR will be pointing it to some garbage location. So the temp variable, by the time when we are using this main function, the temp variable will be destroyed because it is a local. So then that below line doesn't make any sense. So you will get the random address or some garbage value. So that's what. So to avoid this one, you just need to have a create memory objects by using malloc dynamically and use it, and then you just need to free the memory location. So I think that is not the scope of this class, but to avoid the dangling pointers, that is the solutions that are that is widely popular in use. So you can take a look into that, or otherwise if the professor covers, or maybe in the last class I will try to cover that calloc
Uh,
and malloc.
I have a question. When the program have segmented error, like suppose if I have given a code and the question asks like whether it's going to provide a segmented error or not. So how we decide that?
So I don't understand your question. Can you repeat it again?
My question is when a code provides a segmentation error. I mean,
Okay.
suppose if there is a code given and they are what kind of code error we are going to face with this code.
Okay. So basically, if you segmentation fault may be result of uh, many things. So you can't exactly tell that what was the reason. So you just need to, for better understanding, you can have a debugger. You can put the breakpoint and see how the values are changing in the debugger, so that you will
I
see.
mean, just like if in Git such questions ask like what kind of error. I mean, it will provide a segmentation error like something like that.
It might provide the segmentation error and the core will be dumb, but the reason for that core dump you can assess it from debugging. That's what I'm saying.
No, is it not possible like just like reviewing the code we can decide that it will provide a segmentation error or semantic error like?
You can tell that from this code you can say, but if you are very new to the C programming language, you can it is bit difficult, because when you write thousands of lines of code, you can't really point where that particular thing is went wrong. Let's say if you are trying to
I actually, my question is more focused over like, I mean, if I consider like in gate, there are such questions where there is a code given and they ask for what kind of error is going to face this particular code. So, I mean, there might be semantic errors or
uh, uh,
syntax errors,
uh,
or I mean, it may end up as a segmentation fault. So, I mean, I need to know what are the basics to diagnose that. What kind
so
of errors?
you can read more about error handling. So there are different kinds of errors are there. So you just need to explore. So there are syntactical and semantical errors and memory based errors, and sometimes you can get the warning. So if you see, you can see, so stack memory, you can, from this warning itself you can see that you are eventually going to get a garbage value. So you
No,
need
no, I do understand that,
uh,
because and I can see the warning, but in the examination or in the completing examination, I don't have this, check that
you don't have this.
I have
So
to look the code and analyze the code.
yes.
So a syntax error is like, if a grammatical error, then syntax error. If a logical error, then semantic error.
Mm.
But I mean, suppose if I ask the question asks like whether it have a segmentation error or not. So is it possible to detect through the code? I mean, if you can just that it will provide a
you
segmentation error or
you
not.
just need to go by elimination process, that's it. So you just need to check whether it's semantic error then syntax error, but ideally we can't tell it, maybe it might depend on the question. So you might see that some questions are straightforward and you can see that okay, this might lead to some undifferenced occasion, but eventually if you are trying to access the variable which is out of scope, then you can say. But there might be the cases they might ask you the questions that, let's say if you have an array of size 4 and you try to access the pointer and you try to dereference it plus 5, so that means it is out of scope. So then you might get the segmentation fault or something like that. So but at the high level you just need to go with the logic, that's it.
Okay, thank you.
I think I have provided some references as well for digging more into this pointers. So I highly suggest everybody to take a look into it after the class. So let's try to have a quiz. I think we are running out of time, and we will try to have the quiz, and then I will take some questions. If you have any questions, I will take some questions. So yeah, so this is the first question. So the bisection method is used to find what? So could you please send it again? What Pujita, I don't understand. uh, could you please send it again? What I need to send? Okay, reference PDF. Okay, I will upload the PDF in the description box or description of the YouTube video, or otherwise you can check the chat. So there you can, you can check there is some Excel page for PMRF NPTEL tutorials, right? So you can check from there also. Okay, I will try to share after the class. So okay, you want me to show it again? Anyway, you can check that, no issues. So option C is the right answer. So mostly most of you are right with this thing. So it will find the root root of a function. So let's go to the second question. So in which sets the beginning of the list? Okay, 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 most of them seems to be right. So it is a linear search. So it will access the element sequentially and it will try to do the search one after another by incrementing the index. This is right answer. Okay, third question. I think this quiz seems to be easy.
D.
Yes, yes, D is right answer, because you need to have a ordered list to perform the binary search. So this is right answer. Okay, here we are finally at the pointers. Okay, Sushma is saying that yeah. Pratiksha is also a. Okay, can Sushma, can you unmute yourself and answer why it is a, or Pratiksha, anyone?
Hello.
Yeah.
Yeah, it is A because 23 is start num plus 2 of 0. Num plus 2 is nothing but
Okay.
second row
Okay.
and 0th column. That is
Okay.
first column.
Okay.
So it is 3 2. The array is of 3 rows and 2 columns. So 2 5 11 17 23 28. So the answer in the second row and
Okay. So
0th column is 23.
okay.
And the next is star star num plus 1. So num plus 1 is nothing but number of 1.
Okay.
Star star is nothing but number of 1 0. So 1 0 is nothing but 11. So
Okay.
I thought that the answer
Okay.
is 23 11.
Yeah, it is right. So 2311 is right answer. So we are basically start num plus 2 of 0 will point it to the 2 0 location, which is of when you try to dereference it, you will get 23. So star star num plus 1. So num plus 1 means first row. Star star means you are trying to dereference it twice, and which will be, I mean, you will get eventually get 11. Got it? You can try this code and you can tweak the code and explore it, but the right answer is 23 and 11, which is option A, because the first one is like I intentionally try to put this question because you need to understand how to dereference the single pointer and multidimensional pointer. I have explained both. So num plus 1 0 1 2. So here are 2 means num plus 1 means the third row. So you just need to, three things you need to understand. So first you need to get how to represent the array based on in the matrix form based on the rows and columns. Second thing is you know how to dereference the value in the first go with a num plus 1 or num plus 2. Then based on that you need to find whether it's whether you are trying to dereference it and whether you are trying to use array kind of representation or other kind of representation. So that's why I use this particular question. Anyway, 23 and 11 is the right answer. So yeah, I want everybody to answer this question. So what I did was I defined a as 5. I mean, these are global variables. So a as 5, b as 8 and c as 12. So then I try to define the integer pointer with um, of A of size A, I mean it is a three-dimensional array. So what will be the size of the x? So that's what he I mean the question is about. So assume that integer is 4. So what will be the size of the whole array, pointer array star x? Are you guys are there? Anybody is there? Arshad?
Yeah, I'm
Okay.
calculating, sir.
Okay. Yeah. You can take time. No issues. Okay. Chandu, why it is 320? You can unmute and tell everybody why it is 320. Why you think that it is 320?
Sir, it's
Hmm.
A is 5, B is 8, C is 2, sir.
Hmm.
We multiply that and multiply with 4, sir.
Okay. Why you need to multiply it?
It is 3-dimensional array, sir.
Okay. So I mean, I know that it's three-dimensional array. So why you need to multiply it? So if you have three-dimensional array, then why you need to multiply it? Everything. So you got integer. I mean, there is a logic that you need to multiply with 4 because it is an integer array. That's that I got it. But why we need to multiply?
To get total number of elements, sir.
Okay. Yeah. So you got it right. So basically you, let's say if you have this three-dimensional array, so you need to accommodate um, so x axis you have 5 rows, y axis you have 8 columns, and z axis you will have some 2, whatever it is. So you will have three-dimensional array. It is like a cube. So in order to accommodate such multi-dimensional array, you need to in order not answer is not fine. So answer is 320. He's right, because you need to have you need to have in order to accommodate all those values in that particular cube in the three dimensional, you need to allocate such amount of memory to that particular pointer. So that's why the answer will be 5 into 4 in rows. You need to have those many rows, those many columns, and in z dimension also you need to have 2. So that's why you need to have 5 into 8 into 2 into because into 4, because integer have 4 bytes. So they have specifically said. So 5 8 8 5 are 40 to 80, 8 4s are 320. So that's what the answer is. So finally, yeah, I think first we will answer this question. So we have a float array, and then we are pointing the ptr1 to the 0th element of the array, and then we are trying to do the pointer arithmetic on the array. So first tell me what will be there in ptr2, star ptr2, what you will get. If you get that thing, ptr2 minus ptr1 is easy. So there is
Address of fourth element in PTR2.
So what it will print in ptr2?
It will print the memory address of PTR.
So what the first print statement will print? That's what I'm asking. Here we are dereference it, right? So here we are trying to dereferencing it. So how okay, 12.5. Okay, no, okay, noble, say 90.5. Okay, okay, noble, can you say why it is 90.5? Yeah.
The pointer 1 refers to 12.5, sir.
Okay, cool.
Then it's moving 3 because pointer 1 plus 3.
Pointer 1 plus 3, that means 0, 1, 2, 3. Okay, it will go to 90.5. Okay, very good. Okay, what will be the result of PTR2 minus PTR1? So maybe I will try to answer this. So PTR2 minus PTR1 will be 3. So
0, sir.
no, it's 3 because you, let's say you have the address, let's say if it is 5000, pointer ARR 0 is at 5000. So after 5000 it will shift plus 3, that means it will shift 3 positions. So it will shift 3 times. So pointer 2 will have 5000 some 24, let's say if it is integer of 8 bytes, 888, or it's 444, it is 12. So by doing the arithmetic operations in between these two, so whatever the incremented value will be there, I am trying to print the value. So how what is the increment? So the final value will be 3. So for more insight, so how it happened, that means it is the difference. So 90, so the memory locations, how many memory locations that it got shifted, and from there it PTR2 will be pointing it to 90.5 and PTR1 will be pointing it to the 12.5, and the difference between these two pointers. So here we are not trying to dereference it, just look into it. So when you are doing the pointer arithmetic, the difference between these two is how much the increment will be. So we move 3 positions towards the right to reach the 90.5. So when you are trying to do the pointer difference, trying to calculate the pointer difference, the difference will be 3. So you can I will post this code, you can try to run it and see. So final question, so we will try to I think this should be the first question. So yeah, anyhow, now you are able to you are supposed to answer it right. So what is there in PTR star PTR2? What it will print? Okay, Sushma. Okay, yeah, 65. You are right. So star PTR will point to 60, and the pointer difference between these two will be 5 locations. So it is there at 0, 1, 2, 3, 4, 5. Okay. So I think that's all for today's class. Okay, I think that's all for today's class. What we try to learn here is about pointers. So we try to scratch some surface. So I suggest everybody to sit for some time and do some hands-on on pointers, because this is very crucial. Not for the final exam, not even for the final exam, even though after when you go outside it is there, it is important for GATE, it is important for many competitive exams and all, for your interviews, if you are trying for looking for some IT jobs and everything. So pointers are fundamental and basic. So I suggest everybody to look what is how these things will work. So we try to give you some basic insight, so you try to do some experimentation with this stuff and get a clear understanding about how these things work. So I think I will stop it here, and we will meet in the next class. So if you don't have any questions, I will stop it here. Does anybody have any questions? Seems like nothing. Okay guys, thank you. Let's meet on next week. Have a great evening. Good night. Thank you.
Thank you, sir.
Bye. Good night.